Algebra 1, lesson 1.1. We are finally into the algebra stuff. We're out of the pre-chapter. So the first thing we want to talk about is a couple definitions here of the materials. And the first thing we're going to talk about is what is an algebraic expression right here. An algebraic expression, guys, I already gave it to you. It just consists of sums and or the projects. I got carried away. I was thinking about projects. How about, that wasn't supposed to be there. How about the product of numbers and variables? So again, we should talk about what's a variable again, because I think we've talked about that once already, yes? Yeah. What do we say a variable is? You guys are like, oh, that's X. That's Y. That's Z. Something unknown. Or something that's unknown that stands for numbers. Stands for a number. Right? It's something that stands for a number or something we just don't know. What's a term? A term, guys, can be a number. It can be a variable. Or the product of a number and variable. When I say that, it could be multiple variables. The products of numbers and variables, I should say. Or variables. It's getting kind of small in there. It's variables at the end. Okay? So, factors, guys. A term is just a number, a variable, a product. Here, let me go back onto that. I can call X is a term, 3 is a term, 3X is a term, okay? Those are all terms. Those are all examples of terms. But what does it mean to be a factor or factors? Yes?
Like the quantities being multiplied.
Yeah, it's the things that are, the quantities that are being multiplied. So the quantities being multiplied. So, when I say 3x, 3 is a factor, x is another factor. Together, they make a term. Granted, I could do this too. X minus 2 times x plus 4. Both of those sets of parentheses are called factors. Product. Product means what? It's a multiplication. So the product of something is the multiplication of factors. So it's not too bad today. We've got to multiply things together, possibly talking about what are those things we're multiplying together. And then the other thing is, what is a power?
It is the amount of times a number is multiplied by itself.
Yeah. So you might see something like this. This thing overall is called a power. But it's got two components to it. It's got the A value on the bottom, A, which we call the base, and N, which we would call the exponent. So it's not too bad. But, like Emma says, this means to have a power means you take the base number and you keep multiplying it to itself, right? How many times?
The number that's on top.
The number on top, the exponent. So, if I asked you 5 to the third power, what? Yeah, it's 5 times 5 times 5, 3 times, which would be 125. Is everybody okay with that? So the first thing I want to talk about on this slide, we're going to skip over A and B for now. And we're going to jump to the bottom and say, hey, these are commonly used words. There may be others, okay? But if I'm just going to talk about adding or addition, I may say something's more than something. Now, when we say more than, we're not really saying, we're not using inequalities. Right now we're writing expressions, we're writing equations eventually. Inequalities are when you use the symbols of less than or equal to and all that. You can talk about the sum of two numbers. You can say 5 plus 7. You should be able to write that. 7 is increased by 2. Can you write that? How about 5 is added to 7? Those are all things you should be able to do. Subtraction, we use less than. We use subtracted from. Difference, big one. Decrease by and minus. Multiplication, sometimes you go the product of. The product of 3 and 4 is 12. Multiplied by, times, and of sometimes is for multiplication. And division is the quotient of, divided by, etc. Now, why do we need to know that? It's because up here in these problems, I'm giving you the algebraic expression so that today you tell me in words. And so, yes, I want it all written out. Who can say this aloud? Say that out loud. Someone take a stab at it. Monica.
3x to the power 4.
3x to the power 4. If I said that, Monica says that, we all pretty much can probably realize what it is. Now the question, though, I'm going to change it here, is what if I asked you this? How would you say that? 3x to the 4th power. Uh-oh. There is a slight difference. There is a difference between those two. So I want to make sure that I'm talking about everything that's going on. Ashley.
3 times x to the 4th power.
Yes, that is what I'm looking at. I want you guys to actually write 3 times x to the 4th power. Can you see that there is something happening between the 3 and the x, right? We're separating them. There is something there, even though we don't write it in its multiplication, right? So 3 times x to the 4th power. Any questions on that? Could I have also said the product of 3 and x to the 4th? Sure. That's not a big deal. What about part B? Knowing the information from part A, can you do part B? I got to give everybody 60 seconds. I'm going to pause the video. 5 times, that's actually a z. So, I don't know if you said z or not. I think you said 2, I thought. Maybe not. 5, what? Say it again, Lauren. 5 times z to the 2nd power. Then what? Plus? Plus 16. Guys, is this the only way that it was said? Or is this the only way you can say it? How else can we say it? Multiplied by. So 5 multiplied by z to the 2nd power. Could I say something better than to the 2nd power? Squared. We could say 5 times 5 times z squared plus 16. So there's a couple different options. Not everybody's going to have the same thing, but everybody will have the same thing. Mind is blown. We're finally individuals. Any questions on that? The last 3 examples are right here. Instead of giving you the words to write the algebraic expression, I want to give you the words. All right, wow. Sorry. Instead of giving you the algebraic expression to write the words, I give you the words, you give me the expression. Notice that sometimes it's mixed up. It has numbers as numbers versus spelled out. but a number t more than 6. Interesting. Is it Shara? Your hand up? No? Oh, okay. Ash? 6 plus t. T more than 6. If you know what 6 is, all I have to do is add t to it, right?
It looks like 6 plus plus.
I thought it would be like 8.
Or could it be t plus 6?
We should make it count.
Yeah, we should, but I didn't. Either one of those is okay because addition is commutable, right? Commutative. It goes anyway. Okay, part D. 10 less than the product of 7 and f. Izzy.
Would it be 7 times f minus 10?
Ooh, 7f minus 10. Is she correct?
Yes.
Yes. Now, guys, this one trips kids up the most. Because if I say that I am 7 less than something, or 10 less than something, you need to know what that something is first. And in this case, that something happens to be 7f. And then I could take 10. A lot of people like to put 10 minus 7f. But be careful on the way it's worded. And the last one, 2/3 of the volume V. Who has it? Who has 2/3 of the volume V? I'm going to pause the video so I don't have to wait so long. So, what is it?
I have 2/3 times v.
2/3 times V. How do I write 2/3?
2, and then put a line under it, and then you put 3 underneath the line.
And V, right? 2/3, 2 over 3, and then times V. We don't have to write in there. Homework, guys, is chapter 1.1, page 7, 1 through 34, every 3. Have a fantastic day.
Wait!
Yeah. Sam Drake. Sam Drake with some.
I don't like to go in the stand. We're out of that.
Why do you guys encourage that behavior?
Sam's just matching.
Well,
No, because I know all these kids. Yeah, because I used to go to school.
hopefully you don't go, you got to be a Trojan or you got to go.
What do you mean?
And you get clapped out.
Yeah, that would be so.
You keep the test.
Bye-bye.
Do I have everybody's selfie?
I will.
Yes. Bye.
Wait, so attention start at 7:15 here in the morning?
7:15 in the morning,
Is that every day?
except for Fridays.
Okay.
What's a sneeze bug?
You sneeze in it.
You
You do.